9.6 has to deal with modeling with trigonometric functions. And so we need to know that, well, let's take a look at the word frequency. We know that the periodic nature of trig functions makes them useful for modeling oscillating motions or repeating patterns that occur in real life. So some examples of these are like sound waves, the motion of a pendulum, and seasons of the year. In such applications, the reciprocal of the period is called the frequency. It gives us a number of cycles per unit of time. In this chapter, we're just going to focus on writing a trig function given a graph. And so the graphs of sine and cosine function are called sinusoids. Sinusoids. And one method to write a sine or cosine function that models a sinusoid is to find the values of a, b, h, and k for the sine and cosine functions. And we have our a, b, h, and k here for both sine and cosine. A, we remember that as the amplitude, how high and how low the graph is going. And then we know that the period, our period for sine and cosine is normally 2 pi. But in order to find the period with our b value, we divide it, so it's 2 pi over b. H is the horizontal shift that tells us it's going left or right. Okay, so left or right. And then we have our k value, which is our vertical shift, and that tells us whether it's going up or down. Okay. The one that I want to focus on, or what we will focus on, is knowing what the period is. We have to remember that that is the equation for it, because we need to figure out what is the b value so that we can write an equation. So let's do example number 2, writing a trig function given a graph. So we have the sinusoid below. In order to do this, we want to figure out what is the maximum and minimum values. So we know that our max value is up here at the top, and then our minimum value is down here at the bottom, and the max value is 5. The y value of the max is 5. The minimum value is -1. We want to identify the vertical shift, and you might be able to tell that just by looking at the graph here. And so we have our max value plus the minimum value. So it's very similar. It looks very similar to our amplitude formula. So the difference with finding the vertical shift, it's adding in the center. We have the max value plus the minimum value divided by 2. So it's 5 plus a -1 over 2. So that ends up being 4 over 2 or 2. Excuse me. And so we can see that right here, that if we draw our midline at 2, we can see that is the middle of the graph. So now we want to take a look at whether we're going to model it by using the sine or a cosine function. Now, it could be either one. So in this case, just for now, let's go ahead and focus on where the y-intercept is. Where is a y-intercept of the graph of the sinusoid? And then when you find that y-intercept, where is that in respect to the midline? And so that'll tell us whether or not we want to use sine or cosine. So for example, if we're looking at this graph here, our y-intercept is right at that point at 2, which is at our midline. So because that is true, we'll just say that we're going to model this sinusoid with a sine function. Okay, so we're going to use sine for it. So now we need to figure out what is A, what is B, and then if we have any vertical shifting, our K. So right now we won't focus on shifting left or right. So we need to find the amplitude and the period. So the amplitude you might be able to tell just by counting, right? You take the midline, then you go up to the maximum and figure out what that is. And you can see right here that if you do that, you count 1, 2, 3, you can see that the amplitude will be 3. Now if we use the formula, if we remember the formula is 1/2 of the max minus the minimum value. So if we do that, let's just plug it in. 1 divided by 2, and then the maximum is 5 minus a -1. So when we do that, we get 1/2 of 5 minus a -1, or 5 plus 6. That does equal 3. So our amplitude is, in fact, 3. Now let's talk about the period. So we have to look at where it repeats. And so if we start right at the midline on the y-intercept, it goes up, then it goes down, and it stops right there. So we need to figure out what is this point that it stops at. What is one full period? So I don't see the value here. I know this is 3 pi over 8, but I do see on this side, I do see a pi. Pi is where it stops here. And if I look at that, oh, that's 2 times. It goes through 2 cycles. So if this is pi, I would know that half of it would be pi over 2. So this point over here is pi over 2. So we know that the period is pi over 2, but we need to figure out what is b. So remember that a period is 2 pi over b. So what we're going to do is we're going to set it equal to each other. We're going to set pi over 2 equal to 2 pi over b so we can solve for b. So I'll do that down here. So we have the period pi over 2, that's what it is for my sinusoid. Then I'm going to set it equal to 2 pi over b, and then I'm going to cross multiply. So b times pi equals 4 pi. Isolate the b value. We know that b is 4. So we have a is 3, b is 4. We know that our k value is 2 from up here. K is 2, but we're not going to shift it left or right. So now let's plug in those values into this function here. We have y equals, our a value is 3. Then we have sine of our b value, and the b value, b is this 4, so 4. Then we have x plus k, so whatever our vertical shift is. In this case, our vertical shift is up 2. So here is the equation of this sinusoid. Let's go ahead and try the next 2 examples. Go ahead and pause the video, and when you come back, the answers will be here. So here are the answers for number 2 and 3. Number 2 is a cosine, starting up here. Our period, I figured out that it stopped at 2 pi over 3. And so down here, I figured out that I set 2 pi over 3 equal to 2 pi over b, cross multiplied, solved, and so I know that my b value is 3. My amplitude is 2, my k value is 0, and so I just plug it into the function here. So for sine, I figured it out that the period is 2, and so period is 2, so then I set it equal to 2 pi over b, and I solve for it, so I got b equals pi. I know that the a value is 2, it's stretched by 2. Here's the midline at -1, up 1, 2, and then also down 1, 2. And it shifted down 1 at -1, so here is the function. Let's go ahead and try these out for homework, and it is on Big Ideas.